The hardware is the universe and the stars and the planets and the atoms and galaxies, and the software is the code, the laws of physics. But
Right.
not just like the code. When you have code, you have the qualitative code and the primary instructions, but then there's also quantities involved. And if you just change the quantities by a tiny amount, some of these quantities are very sensitive. You just change them by a little amount, you would think, okay, it changes things a little bit. Atoms maybe change a little bit. But no, you change these numbers by little, there's no atoms, there's no molecules, there's no stars. Everything becomes a mush. You lose the entire universe. Everything falls apart when you change these quantities by little. And that's what fine tuning means, that it's a very, very small changes to these quantities, which you might have initially thought, like, who cares? Whether this fine structure, the ratio of the gravitational constant to the electromagnetic constant, if it's 10 to the 40 or 10 to the 40 is a massive number. It's one with 40 zeros afterwards, right? So imagine if there was 45 zeros or 35 zeros. Still big. Do you think it really makes a difference? It does. It makes a huge difference. So that's what fine tuning means, is that in the software, these quantities, which physicists had originally assumed to be arbitrary and insignificant, exactly why they are that way. And then the question is, well, how do you explain such a number? Turns out that science discovered through fine tuning, which is scientific knowledge, that these numbers are precisely fine tuned in order to produce the hardware, the universe that results.
Okay, so there's two objections to this that I read a lot on this channel, and the first is basically, let's just stop at the mystery. So long as it is a mystery, we don't need to stretch into some implication or kind of stuff God into this gap of knowledge. Can't the gap just be a gap? Can't the mystery just be a mystery? Why are we trying to have some resolution or some conclusion or certainty here? Just let it be what it is. It's mysterious. We don't get it. That's as far as it goes, because so that's the first one that I hear all the time. And then the second one that I hear is that is basically the Douglas Adams argument, right? The puddle wakes up one morning and he thinks, wow, what a perfectly shaped hole. This hole fits me as a puddle perfectly. And they kind of think that perspective of the suitability of the environment for the subject is basically the same thing as like a lottery argument, right? What would be y'all's response to those two objections to the attempt that you're making to say numbers, coding, math, therefore God? And what would you say about these two alternative responses?
So I'll start with the gap question. So basically, we agree that if you would have just had the mystery, imagine someone were to read Feynman's mystery in 1986 or whatever, and he says, this is the greatest dead mystery of physics. How do you explain his numbers? And they said, I'll tell you what, it's God. God made the number to be 1 over 137.13979. That would just be a gap. It's just you have a gap in knowledge. You don't know. You have ignorance. And you're saying, I'll just fill in the gap with God. That wouldn't be providing any insight. That's just saying you don't understand something, so it's a lack of knowledge, and you just say God. That's just an argument from ignorance. But that's not how it went down. At that point, it would be a mistaken methodology to posit God, because it doesn't explain anything. It doesn't follow from anything. It's just a mystery. Okay, you got a mystery, big deal. But science developed beyond that point, and beyond Feynman's mystery, science started to realize, to the surprise of scientists, we gain knowledge about these numbers. We realize that these numbers have to be these numbers, and if they weren't these numbers, then we wouldn't have our universe. We realize these numbers are very, very special in that they are necessary for the purpose of bringing about the universe as we see it. There's a correlation between the precision of these numbers and the resultant universe. And that precision points to an explanation. That's a clue to explaining these constants. The constants are not as mysterious and arbitrary as they seem, but there's a clear relationship. Only these numbers are going to bring about the future universe. And that points to a cause that acts with purpose, and that's an intelligent cause. So it's a discovery, and that's what we mean. It's not argument of the gaps. I don't understand something, so I'll plug in God. This is not I don't understand something. This is I have an indication of intelligence. Intelligence is like intelligence comes from like a Latin word, interlegere, or something like that. That basically means it's like the ability to pick one plan or one thing from amongst many. And the idea is that from the set of all the possible values of the constants, the particular values of the constants are exactly those which are necessary to bring about our future emergence of our universe in all its grandeur. That discovery points to God. So it's not just filling a gap that we don't understand. That's an argument from ignorance. It's an argument from knowledge. It stems from the discoveries that of modern science, which shows that these numbers, we do have knowledge about these numbers. The knowledge is that they're not as arbitrary as Feynman thought. They're specifically the numbers which are necessary to bring about our universe. And that has to be explained. To just say, well, you know what? I don't like that implication. I don't really want to go there. I'll just leave it as a mystery. Well, you're leaving it as a mystery, but you're ignoring the knowledge which fine-tuning has provided with you. That's just choosing to ignore the knowledge. You have to explain the knowledge or show how do you explain these numbers given the fact that they are fine-tuned. And that's what we're arguing, is that knowledge points to an intelligent cause, to the teleological cause, which is a result of intelligence.
Right. There's two other reasons why it's not a God of the gaps argument. Another thing with God of the gaps argument is it's very often like a gap is like a little detail. When you have a problem explaining a detail in something, but you have a good theory, but there's details missing, then just to say, well, hold on a second, your beautiful scientific theory has certain gaps in it, and say, well, there's God coming in and doing that. Or, there's something about a paramecium that you can't explain through evolution. Well, I'm going to say God does that. Then people say it's God of the gaps. But the fundamental constants in nature, they're part of fundamental physics. It's not a detail in physics. There's something we can't explain, how light bends around corners or something like that. It's about the bedrock of all reality, of physical reality, which is the fundamental laws of physics from which chemistry and biology are all derived. And these fundamental constants, they're called fundamental because they're at the basis of reality. They can't be derived from anything else. It's not a detail. It's not a detail in physics. It's the very foundations of physical laws has these quantities and these numbers. So it's not a God of the gaps argument. It's not picking on details in an otherwise robust theory. It's rather saying that the very foundations of physics point to an intelligent cause, because the foundational laws and quantities of physics are those that are needed in order to produce a universe with atoms and planets and molecules and stars.
Right. And the third, go ahead. You want a follow-up question or?
No. I want you to hit the third, and then I got to follow up.
Okay. So the third thing is that a theory of the gaps is a theory which could explain anything and everything, whatever the universe would look like. You can always just say, oh, God did it. That's a problem with the theory of the gaps. So if any theory which could explain anything and everything doesn't explain anything at all. And that's a problem with the God of the gaps. But we're not saying just anything could be explained. We're saying we observe in our universe order and structure, fine-tuning. We see that there is that the constants have a purpose, that the values of the constants have a purpose. They're specifically those numbers which have the ability to bring about our future universe. And therefore, you couldn't just say God, if you just saw a chaotic universe that didn't have any fine-tuning, any design, any order, then it wouldn't be intelligent. It wouldn't be grounded to say, oh, God did it. Why? Based on what? So it's specifically emerging, not just from anything, it's specifically emerging from the evidence which is pointing to God, to an intelligent cause. So that doesn't partake of that flaw of God of the gaps. You can just always say God to plug anything. No, it's specifically say God when he is indicated based upon the fine-tuning or design.
Okay, so this, I think, kind of starts to get into the multiverse a little bit, or at least it explains why I think that view is popular, because to kind of go to the puddle analogy that I was just going to take y'all's side for a second, the difference is that the puddle, because it's made out of water, can actually fit into any shaped hole. It assumes the shape of the hole. Everything that you guys are talking about with universal constants is that actually, no, this universe can only be set according to a very, very, very precise shaped hole. So it's like two puzzle pieces that actually have to fit together, and there's a billion sides of that jigsaw puzzle in order for it to fit, unlike the puddle, which assumes the shape of the hole, right? Yes. So if you only get one at bat with this universe, then the math is extraordinarily in the favor of design and intelligent design as opposed to randomness and chance. But this is where I think the multiverse becomes interesting, because if alternatively you get billions and billions of at-bats, then you can theoretically have a puddle of this shape and a secondary piece of this shape, and it doesn't work, it doesn't fit. And then finally, this one time, the pieces all fit together and you get the universe as we know it. So what is your response to the multiverse defense of that you can have the reality that we currently inhabit sans divinity?
Right. So let me just try to break down that into two parts, the puddle question. There's really two ways you can ask it. One is that the water always fits the shape of the puddle, the hole that it's in. Okay. And that's why it's so important, just the conceptual order of the mystery, then the fine tuning. Is if it was just any random number for the constants, when it was at the stage of the mystery of the constants, that's kind of like that puddle, a random puddle. And you're saying, well, what are the odds that it fits? Obviously, it's always going to be whatever numbers we have, these are the numbers we have. And a random arbitrary puddle, okay, you can't really ask the question. Of course, it fits the shape of the hole. It would be much more akin if you had a puddle that was it was shaped into a model of the entire solar system. If you look at a puddle and it's perfectly formed with, all the planets and the sun and, the asteroid belt, and you go, that's not just a random puddle. There's something special about this puddle where it's exactly mirrors the perfect formation of the solar system. That's a weird puddle. That would demand an explanation. So either a person, you could say an intelligent cause, specifically dug a hole, filled it with water in order to be a model of the solar system. That would be the intelligent cause explanation. Or you can bring in, say, hold on a second. There's trillions and trillions and trillions of puddles out there. And you really, in order to get the one the shape of a solar system, find there's maybe, and let's just say there's an infinite number of puddles. Well, there's an infinite number of puddles, then one puddle, you can have puddles that look like horses and puddles that look like houses and puddles that look like solar systems. So it's not really a question of why you got puddles, a solar system. There's going to have to be one that looks like it, and you happen to be looking at it. So that's much closer. That's kind of like the multiverse type of explanation, right? And your question is, how do we know that's not what's going on with the constants? Right. Okay, good. So that's okay. So what we've explained, the whole fine-tuning argument, that's what we do in season 1 of the Physics to God podcast. We do it over the first 5 episodes as the fine-tuning argument. We actually have 2 more arguments that we do in season 1 based on the design of the laws and the initial conditions of the universe. That's all we do in season 1. In season 2, we're going to take up the multiverse. That's what we're coming out with in November. And we haven't really given it over yet. So this is going to be a fun attempt for us to try to compact it. So maybe we'll start with the different premises that a multiverse needs in order to explain fine-tuning. So go ahead.
Okay. So here's the thing, is that multiverse comes up in a lot of different contexts. Okay, Brian Greene has a book where he has all different types of multiverse. I think there are like 10 or something. It comes up all over the place, the idea of multiverse, and they're all different versions. And that's part of what's confusing. It's hard to tackle or to deal with because it comes up in a lot of different forms. Mm-hmm. But the way we like to think about it is that any multiverse theory which attempts to explain fine-tuning has to have 3 essential ingredients. Okay. The first ingredient is that there has to be, and we call it infinite multiverse premise. There has to be infinitely many universes, or a heck of a lot, like billions and billions and billions and billions and billions. Practically all physicists talk about it as an infinite. There are infinitely many universes. That's the first element which must exist in order to explain fine-tuning. But that alone isn't enough. You also have to have these, what we call the varied multiverse premise. The universes have to all be different. If every single universe in the multiverse has the fine structure constant 1 over 137.13999, that doesn't explain anything. You're still back to the same exact problem, is why are they all fine-tuned? Must be God fine-tuned them all. So multiverse
that would be like if you have trillions and trillions of puddles, but they're all shaped like a solar system. It doesn't explain anything. That's some intelligent person made trillions and trillions of puddles to look exactly like the solar system. You have to have that the trillions of puddles have to be different from each other in order to say, well, one by chance alone would happen to be shaped in this special way.
Right.
So that's the second premise. And that's not so simple. There's no evidence for what we'll talk about. There's no evidence that there are infinitely many universes. But even if you say their theory is something called inflation, which leads to we'll get into it, but leads to infinitely many universes, still you have to also say that these universes are all different, that the fundamental laws of physics, the constants of nature, vary from universe to universe. Okay?
Okay.
Fine. Now, there's the third element, which is the hardest one to explain. Why don't you try to explain it, and then I'll give our analogy to.
Okay. So even if there really are an infinite number of other universes and the constants of nature are different in all the other universes, so then, yes, then by chance alone, there's going to be a universe which has constants that are fine-tuned. And in that universe, which is fine-tuned, there's going to be atoms and molecules and planets and stars and life and intelligent life. And that intelligent life is going to look around and go, whoa, what are the odds that the universe is fine-tuned? And obviously you can't exist. Intelligent life couldn't exist in a universe without fine-tuned constants because there's no atoms in those universes. And there's obviously no life in intelligent life who is capable of asking the question of what are the odds that I happen to be in a fine-tuned universe. That's called the anthropic principle, and that's what the multiverse tries to solve. It just says, since there's an infinite number of universes with different constants in each one, then it's no question why you happen to be in a universe with constants that are fine-tuned, because that's the only possible place that you could ever exist. And that's called an observer bias. An observer is biased by the fact that you can only be in a universe you can only observe a universe with fine-tuned constants because you couldn't exist in a universe without atoms and molecules and planets. Okay. But there's something more. Since multiverse is trying to explain things through chance and probability, you can look at the universe, the set of all universes that have intelligent life or have an intelligent observer, let's say. Okay. And it's true we couldn't find ourselves in a universe without any intelligent observers because there's nobody, that's impossible, obviously. But we could have found ourselves in any one of the other universes which do have intelligent observers. And they're not all the same. Since there's an infinite number of universes in the multiverse, according to physicists, and they say this openly, Alan Guth says it, and they all say it, is that there's an infinite number of universes in the multiverse, and anything that's possible that can happen will happen, and each one happens an infinite number of times. So every type of universe exists. So let's go start slow. So every kind of universe with an intelligent observer exists. There's universes that are like our own, exactly like our own. There's a universe like our own, but this pen is moved over 5 inches to the right. Everything else is the same. There's universes that, Max Tegmark talks about universes that have Smurfs in them. And there's
The voice, maybe.
right.
There's another universe where there's a bunch of people standing somewhere in the desert and they hear a voice from the sky that says, I am God, I created the heavens, I fine-tuned the constants to be exactly this. There's no multiverse, it's all a fake. There's a universe like that just by pure chance. There's a sound wave that happens to randomly produce that sound, not really due to God, just due to random chance. That is one universe. Actually, infinitely many universes in the multiverse contain phenomenon like that. Everything exists infinitely many times in this infinite universe. Everything which is possible is going to happen somewhere.
So now the question is given, let's exclude from our minds all the universes without intelligent observers. We understand that. Forget about that. You can't be there. But now within all the universes which have intelligent observers, which one would we expect to find ourselves in? Multiverse is, trying to be scientific, and this is the way it tries to be scientific and make a prediction. So by chance, you would think you are going to be in the universe, a typical universe. It's called the principle, I think Vilenkin is the one who coined it, principle mediocrity, is you would expect to be in a universe, a common universe, a typical universe that has intelligent observers. You wouldn't expect to find yourself in a universe which has a Smurf, because even though multiverse scientists agree or believe that there are universes that have Smurfs in them, those are not likely. Those are not that common. And that's why we don't observe Smurfs. So we would observe ourselves to be in a universe that is typical. And therefore, we have a check. We have a way of testing the multiverse. It makes a prediction, a type of a prediction, that we should be in a typical universe that has intelligent observers. So even though 99% of universes don't have intelligent observers, of the 1% that have intelligent observers, let's look at those. We would expect to be in a typical version of that, not in one that has all these wacky things that shouldn't occur by chance alone. That's called the typical universe assumption, and that's the third premise that every multiverse must establish, must show in order to be a viable theory. Okay, so we need three premises. You need to show, scientists have to show there's an infinite number of universes. Two, they must show that the laws of nature and the constants of nature change from universe to universe. Because again, if you have an infinite number of universes with the same constants everywhere, you haven't solved anything. And then third, they have to show that our universe is a typical universe in the infinite multiverse. Those are the three premises they must establish in order for them for multiverse to be a viable scientific alternative to explain fine-tuning instead of an intelligent cause.
And what evidence is there for these premises?
Okay, good. I'm glad you asked that. Go ahead.
Okay. So let's take them, I guess, one at a time. So the first is the evidence of the infinite multiverse premise. So there's no smoking gun, which says that there are infinitely many universes, but there's something called the theory of inflation. Inflation is a way to explain our initial universe, our early universe, the Big Bang. Inflation basically is a claim, without getting too much in depth, that the early universe expanded very quickly. And that solves various problems in physics. And the theory of inflation, there's different ways to model inflation, like 100 different ways that you could explain how exactly inflation works. But the simplest of those explanations result in infinitely many universes. The idea is that once you have an inflation once, it happens infinitely many times. And therefore, scientists argue that the most natural way to explain this data is the theory of inflation. The most natural way to model that is something called eternal inflation, which produces infinitely many universes.
Right, that's the first way. Look, we personally don't believe there's an infinite number of alternate universes. We don't really think it's that compelling, but this happens to be the one that the scientists actually have the real scientific arguments. The inflation is a real theory that has scientific evidence basing it, inflation. It solves real cosmological problems, and there's evidence for it. And the simplest way to model it leads to an infinite number of infinite universes. And we're just, if we ignore the problem that are going to happen with the infinities, which we'll get to later on, that's a reasonable thing to do. It's an Occam's razor methodology of it's reasonable to model a theory in the simplest way, making the least amount of assumptions, as opposed to just trying to, rig it in a way that's artificial. And the natural way, and since inflation is a real theory and the best way to model it leads to an infinite number of universes, scientists say they have evidence and support that there's an infinite number of other universes. It's not proof, but it's a good argument, and there's justification for it. And, in our season 2 of Physics to God, we grant them this premise. We say we're not going to disprove multiverse or reject it because you don't have real evidence that there's an infinite number of other universes. If this is what you want to rely on, it's something. It's something. Compared to everything else that's going to follow, this is actually the best thing that they got going for them. So
can I say really quick, just on this point, and this is a genuine question because maybe you guys know the answer to this, but what are they actually observing to make this theory?
Okay, so obviously they don't observe other universes. And certainly not an infinite number of them. The observations are, they make observations in our universe. There's certain problems. It's like, for example, one problem is the horizon problem, where if you look in different directions in space, every direction you look, the temperature is about the same. Even though when you look very far away, places are separated by billions of light years, that there's no way they could have interacted with each other since the Big Bang itself, yet they still have the same temperature. And that's not something that you would expect unless there was some coordinating mechanism, and inflation solves that. It solves that by saying that they were in causal contact and then the universe expanded very much afterwards, and that's why it seems like they're too far away. There's a problem called the flatness problem. Why is the shape of space itself so flat, so close to flat? And again, inflation solves that. It smooths out space. So there are genuine problems in cosmology that the theory of inflation itself, inflation just means that there was incredibly rapid expansion the first fraction of a second the universe is around. And that solves certain problems. There are alternatives to inflation. Roger Penrose, Paul Steinhardt have other alternatives. So it's not the only theory, but it is the mainstream theory accepted by cosmologists that our universe had a very period of rapid inflation right after the Big Bang. And it's based upon evidence in our universe, the cosmic background microwave radiation, inflation predicts certain irregularities in it that show up in the data. So it's a real scientific theory, inflation itself.
Okay, fair
But then
enough. But then, can you help me understand again? Because I'm slow. How is Occam's razor beginning with inflation that we have an infinite number of universes? I don't follow that.
that's a good question. It's because when you model, there's different ways to model what causes the inflation. So it's the thing called like an inflaton field, that they have to posit a certain field. And when you posit that field, when you posit the mechanism that causes inflation to occur, the simplest way to model it, that's the Occam's razor comes in. There's different ways of modeling it. So unless you want to have like multiple fields that cancel each other out and stop it, is once inflation starts, it like keeps happening in different bubbles in different regions. And you'll end up with different bubble universes that are disconnected from each other with like areas in between. And that's like it's the idea of once inflation starts, it's you end up with these false vacuums and true vacuums. It's essentially the idea is once you model inflation in a simple way, it naturally leads to an infinite number of bubble universes that are disconnected from each other. So you start with our one universe, and then when you try to create a physical model to explain our one universe, it ends up naturally resulting that there are other universes that we can't interact with.
Within that model, do they concede that things are, for lack of a better word, progressing or blossoming from a particular beginning point in the past?
You mean like, does eternal inflation assume a beginning?
Well, does it? Oh, sorry, what
Our
was that?
universe or overall from like this whole thing?
Well, I know that our universe appears to have begun at a particular point in the past,
Right.
based on the shift in red light from distant galaxies and a number of other things, like you said, the background microwave radiation. But my question is, those are things that my understanding is that we can actually observe those things and then sort of back extrapolate to a beginning point in the past, But my question is, what are you observing to get before that beginning point to make the prediction or the theory that there's more than that beginning point, that beginning point has something prior to it? Does that make sense?
Yeah, I understand what you're asking. That's a good question. You mean, how do you know there's something? Are you asking? Maybe I don't. You're asking, how do you know there's something before the Big Bang? How do you know something before the Big Bang that leads to these other universes?
I guess yeah. I mean, again, forgive me if I'm out of touch
no.
with all this, but it's like, okay, so if I see, I mean, this is a really basic analogy, but if I see a baseball flying through the air at a particular trajectory, I can follow that parabola back to its source and conclude the speed, the location, the direction of when it cracked against the bat. And I can basically, based on my present day observation of what the ball is doing, understand probably how did it get to where it got. But how do you get from there to that there were an infinite number of other baseball games that took different parabolic trajectories?
Right. Right. You're asking is, how does inflation itself lead to, just because the universe is expanding really quickly, great, but how do you get other universes?
Yeah, how do you, like in particular, what is actually being observed that gets you out of just this baseball game, this ball, this bat? Again, a basic analogy, but how do you get, based on observation, to anything other than just that, basically?
Right. So let me see what would be a good way to explain it.
Maybe an analogy.
Yeah.
Tell me if this is good. It's like, let's say you have like fireworks. So when fireworks explodes, then you have all different like red, whatever, different colored things flying through the air, right? Now, let's say you imagine you just saw one little piece of a red going through the sky. You had like blinders on, and you just saw that one little region. You try to explain, well, where does that come from, right? So you'd say, well, how do you just get one little red thing flying through the sky like that? How does that occur? So you say, well, the best way, there could be a lot of different theories about how you explain it, but one way to model that, how that came about, is based upon a firework. There's a firework there, and a firework, I know what produces that one will also produce many different things flying out in all different directions. So even though I'm only seeing one of them, when I try to figure out how do I explain the cause of that one piece of red light going through the sky, the best model for explaining that is a firework. And when I try to, explain that, I could predict that there are also going to be things flying out in all different directions as well.
But don't you have to know what a firework is to begin with in order to use that logic?
Yes, but you have to model the laws of physics. So the firework here would be like the laws of physics. So the idea
Okay.
is like when you see this one universe, and we see that what Aaron was talking about, the horizon problem, the flatness problem, and we study the properties of the Big Bang in cosmology. When we try to explain our universe and inflation, so when our best theories of modeling it lead us towards suggesting that there are also other red universes popping out all over the place as well, based upon our models, our scientific models. Now, again, that's assuming inflation is right, or assuming we understand fireworks, but that's just presuming that we do understand that. There are other theories out there, and that's why we don't think it's convincing that that's the case, but at least it's based upon like solid scientific modeling, based on
Okay, so that's what I was going to say. Let me take us out of this rabbit hole because you guys got me curious there for a second. So you're saying, okay, fair enough. We'll grant you one of these three, kind of. And personally, I'm not really, I need to.
I know.
But okay, but let's go there. And now, but you were saying, so let's go to the other two then. You were saying that there needs to be a infinite amount of variety or differences between the infinite amount of universes. Infinite amount of universes that are all identical does nothing.
Yeah.
And so anyway, maybe talk about that. What are we observing to?
Yeah, let's talk about that. Okay, yeah. So that's the problem. That's a major problem. We ultimately we end up granting that also, but that's a major problem. And the problem is that the laws of physics, which, for example, inflation, which allows us to derive the existence of infinitely many universes, those laws themselves are fixed laws. There's no indication that these laws change from universe to universe. All of our evidence of the laws of physics, anything we observe is based upon, as far as we could tell, these constants are constant. Our laws are laws. They're fixed. They never change. So even if you were to somehow discover that there are these other universes out there, or there's a mechanism of inflation generating all these universes, based on what are you suggesting that the laws or constants change? There's no direct evidence that on the surface we've seen on the contrary. They're fixed. As far as we can tell, they're always fixed. Now, one line of reasoning, and this is shocking, surprising, but one line of reasoning, which is suggested by Max Tegmark, who's a physicist at MIT. So he says something like this, is that how in the world are you going to explain fine-tuning? How could you possibly explain the fact that our constants are fine-tuned perfectly to be able to bring about intelligent life, to bring about everything which we see? There's no way to do that if we really only have one universe, or even if we have infinitely many universes where the constants are the same. The only way to explain that is that, of course, assuming God doesn't exist, because that can't be. So assuming that, so the only way to explain our fine-tuned constants is that there really are infinitely many universes, and that those universes vary, the constants vary from universe to universe. That's the proof that they do vary, because if they didn't vary, there's no way in the world to explain the fine-tuned constants. Which to us is shocking because it's totally taking this hidden premise that God doesn't exist, which, again, many scientists have this hidden premise. They just assume it. The physical universe is everything that there is. And once you front load that premise that God doesn't exist, then there's no other way to explain fine-tuning. And therefore, they use fine-tuning itself as an indication that the constants vary from universe to universe, which is, again, we think totally... You can't start with that assumption. The question is, What does our universe indicate? Well, fine-tuning indicates we see one universe, we see the constants are fine-tuned. That points to an intelligent cause that fine-tuned them. You can't just say, well, pretend that's impossible, therefore we must be that there's infinite varied multiverse. So, I don't think I have to convince you.
No, that makes sense though. And let me, if we have time for it, let me tease to. Maybe we can get into this a little bit at the end, but that is how us Christians feel about the resurrection. Is don't begin with certainty that it didn't happen and say that can't possibly be the explanation for the rest of the surrounding historic events. remain open to that possibility and analyze all of the evidence objectively. And, but anyways, we can get into that later. But what you just described is what I'm often articulating, but related to that event, is like, don't just say that definitely didn't happen. God definitely didn't do it. We'll never look at that, and like I said, we feel similarly about that. But anyways, I digress. So what's the third piece?
Oh, wait. So the second way they try to establish that the constants change from universe to universe is what's known as string theory. Okay, so this is how string theory comes into multiverse. String theory was in the maybe it's 1990s. It was in the early 2000s. It was the hoped for unification of gravity and quantum mechanics, and it was hoped to be the ultimate theory of everything because it could put together all the forces of nature, and it was the sought after, what the physicists hoped would be the ultimate final theory. And it was hoped that it would be unique in the sense that there would only be one possible mathematically consistent version of string theory, and that we would have discovered it, and it would be the ultimate explanation of everything else in the universe, and physicists would be able to explain everything in the universe because they know this one unique version of string theory. There'd be no other versions. Now the problem came in is that string theory, in order for it to be mathematically consistent, has to posit 9 spatial dimensions, which is obviously a problem because if you look around the world, you see there's 3 spatial dimensions. You can go backwards and forwards and left and right and up and down. And in order to make sense of the other dimensions of space that string theory needs, they said that the 6 other dimensions are like curled up really tiny, really small, compactified is the technical term, so that you can't really see them. We'll give an analogy. The classic analogy is an ant on a rope. From a distance, an ant on a rope looks like you could only go in one dimension back and forward. But it could also, when you look close, you can see it goes around, but it's just really tiny, that it can also go around the rope. It's like another dimension. Mm-hmm. So basically, string theory has these extra hidden dimensions of space that are really tiny and small. And it turns out that the constants of nature, the properties of an electron, its mass and its charge, it depends on the shape of those hidden dimensions, because I don't get into the details, but it is based on the way that the geometry and the shape of the hidden dimensions, how they're curled up and compactified, that will determine the mass of an electron or the charge of an electron. So everything was great, and physicists hoped that they would discover the actual shape of space of the hidden dimensions, and there'd be one theory, and there'd be a theory of everything. But it was discovered that it turns out that there's 10 to the 500 different possible versions of string theory of the way these hidden dimensions can be curled up and compactified. And depending upon 10 to the 500 is a 1 with 500 zeros. That's a big number. Depending upon which version of string theory, you end up with electrons that have different masses or different charges, and all the fundamental particles have different properties based upon this geometry of space. And there's 10 to the 500 different types. So that was very bad for string theory because it meant string theory was not a unique final theory, which was what they were hoping for. And it almost caused physicists to give up on string theory until 2005, when Leonard Susskind, he's the one who kind of married eternal inflation and the infinite number of universes that come from eternal inflation together with the 10 to the 500 different versions of string theory. And he said, maybe it's not such a bad thing that string theory has all these different types of possibilities. That's only a problem if you're looking to explain one universe, which is what scientists had been doing for hundreds of years, trying to explain our one universe. But he says now, because of eternal inflation, we have an infinite number of universes. Maybe all the different versions of string theory are actualized in something called a string theory landscape. And it's populated, meaning all the different versions exist. And there's different universes with different shapes and hidden dimensions. And therefore, different combinations of some electrons are big, some are small, some have different charges, and some have smaller and bigger charges. And he says that now that's great. Now, if that's the case, you can, in theory, try to explain fine tuning, because there's 10 to 500 different versions of string theory. Every one exists in all the infinite number of universes in eternal inflation. And of course, we're only going to be in the universe which has the shape of the hidden dimensions curled up in exactly the right way to allow for electrons to be really small, have the right charge such that atoms and molecules and planets can form. so that you can get in life and intelligent in life to be around to ask the question to say, hey, look at this amazing world of string theory that we happen to have. And that's essentially the best argument that scientists have, is turning the constants of nature, which seem to be fixed values, saying they're dependent upon the dimensions of string theory. And those dimensions are dynamic. In theory, they could change from universe to universe, and it makes it more plausible, more reasonable to say that the constants change because the dimensions of string theory change. And that's their best argument. And on our podcast, we give them this argument too. We think it's very weak. And the only reason we give it to them is because we have a better way to knock them off and to show reject it. But the problem.
So you're giving them all three, basically.
No, we're not giving them the third. We don't give them the third premise.
Oh, so string theory was a subcomponent of two.
String theory is a justification for why you would think that the constants change from universe to universe. Because they say maybe string theory is true. Now, again, string theory, there's no evidence for hidden dimensions. Nobody's ever observed these hidden dimensions. Mm-hmm. They're too small to see. So they're, right. Everybody, it seems like we have 3-dimensional space. But okay, nobody's ever, string theory has never made a prediction that's been tested by any scientific theory. It's been around for over 30 years now, more than 30 years. It's never made a prediction. It's never made contact with reality. There was a thought that one of the predictions of string theory predictions would be supersymmetry. We don't get into the details, and that would be found in the Large Hadron Collider in CERN. And that was not found about 10 years ago, 2015. And since then has not been found. And because of the fact that string theory has made types of predictions that have not been discovered, they could always tweak string theory, because again, there's 10 to 500 different versions. You can always say, oh, well, you can always make a different version to explain why you don't observe something. So you can never it's impossible to disprove, but nevertheless, most versions seem to predict we would find certain things in the collider at CERN, and they were not observed. And so string theory is much less popular now than it was even 10 years ago. So string theory itself is not quite as popular. It's never made contact with reality. The hidden dimensions have never been observed. So it's not really a very strong theory, string theory, but it's a beautiful mathematical theory. And it was very popular 10 years ago. And it's the best that physicists have for argument and justification for thinking that the constants change from universe to universe. So we just grant them that also. Let's just assume eternal inflation is true. There's an infinite number of universes. Let's assume string theory is true. And every different universe has a different version of string theory. And therefore, the constants of nature change from universe to universe. Now, they still have to show, if that's true, that the typical universe with intelligent observers looks something like our own. Right? And now that's the big problem. That is the major problem. A lot of people don't appreciate this point, why it's necessary and why multiverse fails to do this. Physicists appreciate this, but when you see multiverse presented in a popular way, people very often fail this third critical premise, why it's so necessary and why they fail so miserably at establishing it. So go ahead, Elie.
Okay, so here's the thing. Physicists are trying, the way to explain, as we said, in a true multiverse, in an infinite varied multiverse, everything that's possible is going to happen infinitely many times. You're going to have voices which are saying the multiverse is false. You're going to have Smurfs. You're going to have anything and everything happening. So how do you ever...
I just want to add, they also have resurrection. We saw an article by multiverse scientists where they were saying, there is universes in the multiverse where you die and you are resurrected. Every person becomes resurrected. And then the other physicist says, this is getting spooky here, because like they're really, and this is not just, multiverse scientists believe that there are universes, because everything possible happens will happen. There are universes where you die and you become resurrected, and that happens to everybody else, but just by chance, pure chance. And they really believe it. They just will say that the typical universe doesn't have that, but they believe that happens and that there's an infinite number of universes with resurrection. Because again, this key point, whatever happens an infinite number of times, because since there's an infinite number of universes, every type of copy has duplicates and an infinite number of duplicates. So I just have to point out that irony, but go ahead.
That is funny. Infinite plagues, infinite Red Seas parted, etc.
Yeah, they believe in it. They really believe there are universes where the Red Sea parts and the Jews pass through and the Egyptians get drowned, and that happens in universes in the multiverse because everything possible happens. you know, and
So
it's just
funny.
ironic that they believe that, you know, just that
Right.
something crazy has happened here. So, but go ahead.
Right. So the way that they get out of these problems, how do you explain anything? If you're saying that everything happens, that's like a multiverse of the gaps, as you could call it. It's like once you could explain everything, you explain splitting the sea, you can explain fine tuning, you could explain everything. So now you don't have a theory anymore. So the only way
Yeah.
to get out of this is with what they call the typical universe premise. The claim is that of all universes that contain intelligent observers, ours is the most typical. Okay, that we would predict that yes, it's true there are infinitely many universes out there, but we wouldn't predict splitting the sea. If we saw splitting the sea, that would shake our confidence because that's not something which would be expected in a typical universe. But the claim is that what we do see in our universe, if we just look around and we see a fine-tuned constant, this is the typical way to get intelligent observers. That's the claim. Now, here's the problem. What does typical mean? So arguably it means a type of probability. What would we predict? What's the likelihood of getting a universe that's like our own? And the claim is that our universe is likely. It's probable that we'll get a universe that looks like ours. Now, here's the problem. How could you?
We'll do Boltzmann brain first, no?
Okay. Okay, fine. So the Boltzmann brain is like this, is that there's different ways to get universes with intelligent observers. One way is to have our universe. And our universe is this massive universe which has Earth and has all the people who live on Earth and has 100 billion stars in our galaxy and 100 billion galaxies, this massive universe. But there's another way to get an intelligent observer, which is just for what they call a quantum fluctuation of a brain. Perhaps you've heard of this, sometimes known as the Boltzmann brain problem. And the idea is that my brain and your brain and everyone's brain has a certain configuration of particles. Ultimately, it boils down to elementary particles. And you could have a random fluctuation. This will happen infinitely many times in the universe, just a random fluctuation of one brain, which is configured exactly like my brain is right now, with all my memories and everything. And if that's the case, all you need is my brain lasting for a second for me to think all the memories that I have could just be explained by this configuration of my brain. Not that this whole universe, everything out there really exists. Maybe all I have is just a brain. And the point is that in an infinite multiverse, it would seem that the most likely way to get an intelligent observer is to have just a brain, just a Boltzmann brain, which is shocking. You don't want to say that. Or another way to get an intelligent observers in an infinite multiverse is just to have our planet alone with all our observers without all those other stars and other galaxies and all that. The idea is that multiverse scientists are claiming that our amazing universe in all its grandeur, all its complexity, is not just one brain and it's not just one planet with all the human beings on it, but it's our entire universe. And everything about it is the most typical way to get intelligent observers is to get our universe. And therefore, in a certain sense, there's an irony that multiverse scientists are explaining our entire universe based upon man. The most likely way to get man is to be able to have this grand universe. And everything ultimately, as they call it, the anthropic principle, everything ultimately becomes man-centered, which again is a funny irony because that was, religionists have always said something like that. And scientists are like, no, the stage is too big for the actor, for man. The bigger universe is so big. But the scientists maintain the most likely way to get any intelligent observers is our universe. And that's the claim which they have to make. Now, the problem is, how do you measure such a claim?
Okay, so so there's, before I get to the measure problem, just the Boltzmann brain problem, it's a real problem in the literature. You read through, and there are papers and articles by real scientists, the top guys, about dealing with Boltzmann brains. And the technical term in the literature is called freaky observers, And the problem is, how do you minimize these freaky observers that it becomes far more likely to get these brains than to get actual people and actual humans. So that's just, it sounds ridiculous, a Boltzmann brain problem, but it's because multiverse is such a ridiculous theory that it generates these ridiculous problems of that you are most likely a brain. And like multiverse scientists, that they're following the logic of multiverse to its being honest, it leads to the conclusion that they're just these disembodied brains that are fluctuating into existence, have false memories, and fluctuate out the next second. But I just got to just emphasize the point. It sounds ridiculous, but this is a problem they deal with. Okay, the biggest problem beyond that is it's called the measure problem. And this is what multiverse scientists recognize as one of the major problems of multiverse. And it has to deal with, again, this typical universe assumption. Multiverse has to, in order to avoid being a ridiculous theory of predicting Smurfs and resurrections and Red Sea splitting, it has to say that we are in a typical universe with intelligent observers. In order to do that, you have to be able to take a probability. The problem is because there's an infinite number of every type of universe, and every type of universe gets repeated an infinite number of times. So it's impossible to say in any straightforward manner which universe is more likely than any other. If you're dealing with version an infinite number of times, so how can you say whether the universe with just one Boltzmann brain is more likely than a universe with, 100 billion stars and galaxies? Is an infinite number of both of them. It's impossible to make any predictions. So in order to do that, scientists have to introduce something called a measure. Okay, a measure is an ad hoc external thing that you impose upon the laws of nature from outside. It's not part of the laws of nature. It doesn't emerge naturally from them, but it's something that they impose upon it. And just, okay, we're not making this stuff up. You can Google the measure problem. The measure just tells you the way you figure out probabilities. It says this type of universe is more likely than another one. And it's akin to saying, well, when you're lining up these tiles on the floor, instead of just doing, randomly an infinite number of red and blue tiles, do 3 red tiles, 1 blue tile, 3 red tiles, 1 blue tiles. And you got an infinite bag of both. Not going to be a problem. You'll get an infinite number. And then after a million tiles, if you follow that pattern, the measure is like the pattern. And then you have this thing called a cutoff, which just says after a million tiles, just take a check, look at how many you have, and see what the ratio is. And it turns out it's a 3-to-1 ratio because you've imposed that pattern from the outside. That's what a measure is. It's this artificial imposition on the laws of nature, which says these types of universes are more common than others. And then at some point, you just cut off the number of universes, you take a look, and you try to evaluate which universe is more likely. And that's the only way possible for scientists to establish a typical universe assumption, because the infinities of eternal inflation make it impossible to actually tell you what a typical universe is without imposing a measure. Okay, now, what is the problem with measures? Okay, the first problem with measures is that they're ad hoc. They don't emerge from the laws of nature. They're just an external constraint which is applied from the outside with no real justification, other than the fact scientists want a multiverse to explain fine-tuning because they don't believe in God. But there's no real reason to believe there's a measure which selects out which universes in an infinite multiverse is more likely. So it's just a total ad hoc addition. And again, physicists attack. There are real physicists in the world like Paul Steinhardt, Roger Penrose, and they I shouldn't say they're all real physicists, but there are physicists who hate the multiverse because they think it undermines science, which it does. And they're the ones who write papers in Scientific American. They have these articles. So we're not making any of these science stuff up. This is all we're giving you all the things that physicists say themselves. So first is it's ad hoc. Two is all the measures that, let's say scientists try to find measures that will make our universe typical and a normal, average, mediocre universe. And every measure they try, that the universes with more volume are more likely than other universes, or different things. They even have a Boltzmann brain measure. They try, and none of them work. They don't actually work. They don't actually say that our universe is typical. It comes out that Boltzmann brains are more typical using the different measures that they use. So measures are ad hoc. The measures that they've all tried, all the intuitive, reasonable measures, whatever that means, don't actually work. And now they're searching for the past few decades. It's been going on for decades. They're searching for the measure is the ultimate cause of reality and makes this universe the most probabilistic, typical universe. And that's why we live in this universe. And that's their hope that they'll discover this measure, which even if they did, you're going to ask a question of, well, who chose that measure? There's all these other measures that were more intuitive and simpler that you discarded because they didn't work out. So why does that measure exist as the foundation of reality, not all the other measures? They're going to be back in the same question of a fine-tuned measure. And even if they did find this measure, which is a garbage theory to begin with, it would still be designed and fine-tuned. The whole thing is so bad. And when you understand the measure problem in its full scope and glory, you'll realize why we give them an infinite number of universes by eternal inflation, and why we give them the varied multiverse assumption through string theory. Because at the end of the day, they need to establish a typical universe premise in order for multiverse science to be not total, ridiculous, fake garbage. And they can't do that. And they have to do it with these measures, and these measures just simply don't work. And that's why we're going to do this at length in season 2 that we're coming out with in November on Physics to God podcast. We're going to have 14 episodes dedicated to it. It will be clear. Elie does analogies. I speak a little fast, maybe it's a little complicated, but we really make it accessible to everybody. But it's really important to understand breaking down the multiverse, and just to realize that, don't argue with them about, it's not worth arguing with them about eternal inflation. They have such problems at the very root of multiverse that once you understand it, you'll just see that it's just not it's not a scientific theory. It's a philosophical theory that's very bad and just does not stand up to any type of real analysis.
Right. Just to give the quickest summary is that it's very easy to just say multiverse, that's ridiculous. They don't have any evidence for that. And we do share that intuition. But at the same time, there are top scientists, top physicists who believe in it and are writing papers about it. And therefore, we think it behooves us to take it seriously and to really, this idea of breaking it down, this is our idea, is breaking it down into its components, figure out what's necessary, why is it necessary, what are the supports, and this is what we're going to do slowly, carefully. And we think once we do that, it still ultimately falls prey to the same problem as they're making this up and it doesn't work out. But at the same time, it's much more convincing when you go through it slowly, carefully, and see what they're saying and why it doesn't work. So Aaron talking quickly, and I didn't interrupt him. And, we do this. If anyone's going to listen to this podcast, we talk very slowly. We have a lot of examples. I know this is complicated, and I'm sure we lost a bunch of your listeners, but we're going to do this in much more depth and slowly with analogies and, so I just don't want to.
Well, I appreciate that, and I don't think there's anything wrong with fast talking, and I think there's a lot of people that are going to appreciate this. I mean, honestly, I feel that I've learned during this deep dive into the multiverse, and so let's kind of pull back a second though, just to remind ourselves of the original context of going into the multiverse was that it is probably the biggest way of refuting the implications of the fine-tuning argument. The fine-tuning argument seemed to point toward intelligence of some variety. And so, but multiverse, again, we kind of said that's kind of the go-to, or at least one of the major go-to. Well, wait a second. If this is true,
it is the only explanation they have that answers fine-tuning. It is the only way they have, other than just saying wait and see. Which is, again, you can't say wait and see by fine-tuning because we have scientific knowledge. That's why it's so important, the thing with the mystery. You can't just say wait and see. Wait and see works when it's the mystery of the constants. There's knowledge of fine-tuning. It's a scientific discovery. Don't say wait and see once you waited and we saw and we discovered fine-tuning. Now, the only way to explain fine-tuning, there's only 2 ways left, and that's either an intelligent cause or the multiverse. And that is why we had this fine-tuning argument. It was more than 15 years ago. And we never really bothered to develop it or to give it over because you're just like, how are you going to convince people about fine-tuning? It's just hard. You're going to go around talking about physics. How are you going to convince people fine-tuning is a real problem? This is over 15 years ago. And then I think it was maybe 12, 13 years ago, I just came upon, Martin Rees's book, magic, just six numbers. And then he goes through fine-tuning the whole first half of the book, first 90% of the book. In his last chapter, it's all of a sudden it's multiverse. And that was the first time I came across it. I'm like, oh my God, they're saying multiverse. And then I just, I went on YouTube and there's the top physicists in the world are explaining the multiverse. And I just realized this is the way you can show people that God exists. It's not really through fine tuning. It's through the multiverse. If you want to know that God exists, Google the multiverse, watch videos about the top physicists, the smartest people in the world, try to justify the multiverse, talk about how it explains fine tuning. Because when you see that the smartest people in the world believe in an infinite number of unobservable universes where everything happens and all this joke happens, you just realize what is going on. That's why we think the argument from physics is much better than the design argument from biology. The design argument from biology, you're arguing against evolution, natural selection. We don't want to get into we don't want to knock. We're not trying to knock intelligent design and biology, but evolution it's a real scientific theory. Now, whether it's comprehensive or not is a different question, but it's like science. They're doing science. Multiverse is the alternative in the framework of physics. That's why the fine-tuning argument is so much more powerful, because scientists are saying multiverse. It's not science. It's not good science. It's not even good philosophy. It's bad philosophical speculation. And when you watch videos and read articles and books about the multiverse, that will convince you that the fine-tuning argument is good and solid, and there's a real problem there that really demands the idea of an intelligent cause, because there's no way these people would be saying, scientists would be saying, I believe in an infinite number of unobservable universes, if it wasn't because the alternative is God.
So you're saying you don't have enough faith to believe in the multiverse?
Exactly.
Exactly.
You know it's true. You know it's not true. You can see how multiverse just doesn't work out. And again, there's a bunch of steps, but it's not even fake. It's just wrong. It just doesn't work. The measure problem really shows you why the whole thing just doesn't even work. It's because it's not a scientific theory that's even possible to explain anything, unless you want to just say, since anything and everything happens in the multiverse, then that can explain anything. But then you can explain everything that way, and it just becomes a theory of the gaps, and it explains nothing at all.
Well, you know what's interesting? You brought up biology, and so I'm gonna connect this just by way of example, just to show the point that there are actually a lot of people who have simply been either, I don't know if it's on purpose or by accident, but basically have been led to false information. And so where I'm getting with this is the idea that the universe has just always existed. And so I want to get to that for you guys, but going to biology just for a second, is you'd be surprised the amount of people that I interact with who actually believe that life has been created in the lab, and that they believe that Darwin dealt with origin of life, dealt with abiogenesis, and that the theory of natural selection explains the origin of life. That is somehow taught in classrooms, and I think the reason why is because the primordial soup, as just a concept, kind of has a narrative that starts there and it ends with modern man. And there's not really a clear delineation made that, okay, there's a huge thing here that we don't know how it happened, right, materialistically, which is the origin of life. Then Darwin, once you have the first cell, then, natural selection, and we can debate about that and whatever. But there's a narrative that begins again with the primordial soup getting struck by lightning and ends with modern man. Right. And there's kind of this little like the magician, pay attention to my left hand while the right hand is kind of glossing over this huge problem scientifically. So I just want to say that just to say that many, many people, I mean, millions of even Americans believe that life has been created in the lab when it has not. Believe that the model of primordial soup to modern man is scientific when it is not. Now, again, I'm just saying that parenthetically to sort of set up the stage to talk about another example of this that I come across a lot in the comment section, which is the idea that the universe is eternal in the past, that the universe just is. And I'm curious to hear your thoughts about that.
So that's, it matters if you're trying to argue, for the existence of God or an intelligent cause from the Big Bang. So then you say, cosmology really points to the fact that the universe has a beginning, and there really seems to be a beginning in space-time, a first event. And then to say that the universe is eternal, that's how scientists try to get out of an argument to an intelligent not to intelligent cause, just to a cause, a first cause from the Big Bang. They say that the universe went through cycles and really it's eternal. And my personal opinion is it's much more difficult to prove the existence of a first cause from the Big Bang, because they do have, you could say scientifically there is something before the Big Bang. It's just impossible to observe it or to know it. And I think it's hard to prove just from the Big Bang that the universe has had a beginning and was created, and therefore there's a God. But I will add, once you have the fine-tuning argument and the other two arguments we make in season one, the design argument from the laws and the initial conditions of the Big Bang, the low entropy initial conditions of the Big Bang, which we didn't discuss here, but that's like 1 out of 10 to the 10 to 123rd. It's the most astounding number in cosmology. Once you have those arguments, then you look at the Big Bang, and yeah, we know there's an intelligent cause for the universe because we know that the laws of nature were designed to produce. Gravity was selected to produce a universe with stars, and the constants were selected and fixed in order to produce atoms and molecules and life. So then you say, well, then there's no real reason to say that the Big Bang is not the origin of the universe. It's on its face, that is certainly the proper interpretation. And the only reason that scientists don't do that is because they believe God is impossible and we live in a multiverse, and the fine-tuning doesn't prove God and all these different things. If you don't believe in God, you think God is impossible, then it's physically possible to maintain through the laws of physics that the Big Bang is not the true origin. So that's why we don't use the Big Bang as a proof of God. But we do think, and we'll say this, in season 3, but that once you have all these other arguments, which are convincing on their own and don't have another explanation except for a multiverse, then the proper way to interpret the Big Bang is the true origin, and the universe is not eternal, but it has a beginning.
So what do you make of the now this is philosophical and really not scientific, I understand, but basically the something rather than nothing problem. How do you, what's your best understanding of an answer to that question that is not God?
Meaning, why is there something rather than nothing? Right. So I think ultimately you just have to say that that's what there is. There's no logical argument why there must be something rather than nothing. A priori, I couldn't have predicted it, but there is clearly something. But that, and then we can analyze the something that we observe, the universe, and infer, does it have an intelligent cause? Does it not? But ultimately, you're going to get to God. Why does God exist? You're not going to be able to logically show why God must exist. It's just he does, because we observe his actions, we observe the universe, and he does. Now, there is a certain thing called first principles and axis, something that you just must start with in order to get everything going. In physics, they say that's the laws of nature. In mathematics, it's the axioms. In Euclidean geometry, it's 5 axioms. There's just certain things you have to start with. And the question is, do you start with an intelligent cause, God, one simple existence that causes everything else? Or do you start with the laws of physics? That's what scientists believe. Scientists believe there is a fundamental uncaused reality. They call it quantum mechanics. Stephen Hawking, the laws of quantum mechanics are eternal, and then they fluctuate a universe into existence. So you are going to have to get down to something does exist by observations. And the question is just, what's the fundamental something that's responsible for everything else? But ultimately, why is there something rather than nothing? Is you can't explain that. It's just there is. And you do your best to explain
what we do see based upon that assumption.
I try so hard to see how laws are not necessarily derivative and to put myself in that mindset. And I have a really hard time doing it.
You mean, how could laws be the fundamental necessary existence that just always exists? Quantum mechanics, how could that possibly be?
Yeah, I don't even know. I mean, I'm no longer playing devil's advocate, but that's just an honest admission. I don't see how I cannot wrap. I try to empathetically get into that mindset and that framework and to envision a reality wherein mathematics are the primary thing, or the laws of physics are the primary thing, and they just seem to be essentially derivative. I don't know how else to say it. In the same way that if you said that there just is a moral law that is at the base of all reality, I would say, where did that come from? How is that the case? So, but anyways, it's tricky no matter what. And I know that other people listening to this say, that's how we feel about God. You can't just posit God.
I'm about to do the devil's advocate to you and say that's how people feel about God,
Okay, this is we're going to do this in season 3. The reason why physicists are content to say to some level that quantum mechanics and and gravity or general relativity are the foundations of reality is because it's you see all the complexity and diversity of nature, and then you see that it leads to simpler and simpler laws. And once you appreciate the mathematical structure of them, you start to realize that these fundamental laws, they're few, there's only two of them. Ideally they'll find one. They're looking for one simple, unified, beautiful explanation for everything else. They just don't want it to be God. They want it to be an equation that they can grasp and understand. So your intuition is, how could something that has complexity in it, that has parts to it, that's an equal sign where it's one thing equals another thing, how could that be the most basic thing? Because you're saying there should be something even simpler than that. But they want something that's very simple and very beautiful and elegant, but they just don't want it to be ultimately simple. They want to have some complexity so they can understand it and write it down and put it on a t-shirt and say, here we've discovered the ultimate reality, and it has to have some complexity. And that's why you think it's derived, because it's not absolutely simple.
Well, I'm saying even something a little bit different than that. I'm saying that, again, to use analogy, which only goes so far, that it would be like saying the primary thing is paint. Paint just is the primary thing, and paint, when applied appropriately to the canvas's reality with all this beauty and idiosyncrasy and characters and etc. There's this vast, huge canvas, but the primary thing is paint. And what I'm saying is, paint just doesn't seem to be a sufficient primary thing as compared with an artist.
You're right. It just doesn't, you're saying it just doesn't justify itself. How's that self-justifying that is the ultimate reality? It just doesn't ring true to you. I understand.
Yeah.
Right. I hear what you're saying.
Right.
But anyways, okay, so let's bring this thing full circle for the sake of my memory card, for the sake of time. This has been good. So I feel like we've dove into the multiverse. You guys have granted certain premises, but ultimately unearthed a huge problem that it faces. And you're saying it ultimately doesn't stand up as a legitimate refutation to the fine tuning. And that now, if we're going to look at fine tuning, then you're kind of, the conversation that we were just having, is that kind of where the conversation currently sits? You're either left with just unexplained matter or equations that just are, or something beyond that. Like, help close the circle on your argument, because this began with make a scientific philosophical case for why do you believe that God exists. So I'm trying to just get us toward there.
Go ahead.
Right. Sum it up is that basically, when we look into our universe at its most basic foundational elements, where does science lead us? It leads us to these laws of physics, which have these fine-tuned constants. When we try to we have the constants. When we try to understand the constants, the cause of these constants, we realize these constants are fine-tuned, that the values that they have are not any old values. They're values which are the necessary to bring about the future universe. That indicates that the cause that set these values is a cause that acts with a purpose. Cause that acts with a purpose is intelligent. That indicates that God set the constants for the purpose of bringing about our amazing complex universe with everything in it, including atoms, molecules, planets, stars, and life. The only other way to explain that would have been to posit infinitely many universes which vary and all that, which doesn't work out. And therefore, we're left with the plain indication of the discovery of fine-tuning shows us the wisdom of God, who built the universe in a way which brings about our amazing universe.
Right. Just to one point is we're not just arguing by elimination, saying that you have fine tuning and there's two ways to explain it. Multiverse is no good, so you're left with God. But just, you have to think about fine tuning. You have these specific numbers. They could have logically have been anything at all, and that was the mystery. Mark of intelligence. That is exactly what an intelligent being acts like. It does something for a specific purpose. And this universe is amazing and wonderful. And fine-tuning indicates directly the existence of an intelligent cause. Multiverse is not a natural interpretation. The natural direct interpretation that your mind brings you to when you see fine-tuning is that there's an intelligent cause who selected them for a specific purpose, and there's one universe. To explain a one-ordered universe by saying there's an infinite amount of disordered universes that nobody could ever see, and just by chance alone, one of them happens to be right, that's not a natural interpretation. Is it possible that that's the case? Fine, it's possible. Let's investigate that. When we investigate it, we see it doesn't work out. But it's not because we just eliminate multiverse, we're left with the only possible explanation. Is an intelligent cause is the natural direct inference from fine tuning that there is an intelligent cause that set the values of the constants.
That makes a lot of sense to me.
That's amazing, Brandon. We hope all your listeners agree to that, and we're hoping to spread the word.
We'll see. Yeah, we'll see what the viewers say, but that makes an awful lot of sense to me. And I do think that the point that you guys were making a second ago is important to recognize, that there are, regardless of who is having this conversation, there are biases and there is sort of assumptions that are being brought to the equation. And I think that that's an honest, I think that that's an important thing for people to be aware of. I think that a lot of times I have a lot of agnostic and atheist, listeners, viewers on this channel. And I think that sometimes from the conversations, the sidebars, the emails, et cetera, that I have with them, there's a more difficult time admitting that they have assumptions. Everyone wants to be purely objective, just a perfect scientist, no dog in the race, no volitional motivations, no cognitive interference, no religious. Everyone wants to be able to be purely objective. But I do think that sort of adjacently, but you guys have alluded to some of the reasons why God as an explanation, although philosophically and logically consistent, like with kind of your conclusory statement there, I can understand the cognitive dissonance toward that idea of a designer who is also authoritative, who also has some say in the matter of how life is lived, etc. And I don't want to beg the question or put the cart before the horse there either, but I do think that we should have a part 2 that gets into who is God, because right now we've just established basically deism, theism. There's some intelligence that we don't know what it is. Is it maybe Vishnu? Is it aliens? We don't know, but there's some intelligence. And to me, that's important. And I think it's a very worthwhile exercise, but it's kind of it's kind of like step 1 as far as I see it. Okay. So, 100%. Wouldn't it be, in my opinion, wouldn't it be weird if there was an intelligence responsible for the universal constants, the fine-tuning, and humanity itself, but that being never interacted with its creation in any way? I think that would be weird, but let's start with that itself might be possible. I don't know. Let's explore all possibilities here. Yeah.
That's what we say. So that's like, what, in this modern secular age where just like there's this pervasive belief that it's impossible to show that God exists. So we just like the foundation of all religion is the fact that there is one God who, or shouldn't all religion is that there's a God who created, who intelligently caused the universe and everything else in it. And from there, once you have that as a solid foundation, then you could build upon that. Then you could try to say, well, does he interact with mankind? And what implications does that have on our life, and all those questions? But like, you first have to start off with the idea that God exists. And it's like, that's what we're just trying to show people, is that science, there's this pervasive belief that science shows God does not exist. It is the furthest thing from the truth. Science shows, especially physics, when you see it shine, science shows that there's an intelligent cause to the universe. And the only way to avoid it is this crazy multiverse theory. So it's just important for people to realize that you can take the idea of God and ground it in a solid, rational foundation, a philosophical proof based on science, and that's the starting point. And from there, then you can ask all those other questions. But you have to build upon a solid foundation first, and that's what we're trying to do in Physics to God. We're not really developing divine providence and specific religion. We're Orthodox Jews, but we're not trying to push Judaism. We're just trying to show the idea that science and proper philosophical thinking leads to a convincing, compelling argument that there is a God that is the intelligent cause of the universe.
Right. Yeah, it's really interesting. I guess my last thought as we land the plane here would be that like anything, there's a pendulum that's swinging, and it tends to be the case that we overcorrect in terms of how we think about things. And so I understand that because at a point in the past, we heard rumbling in the sky and lightning, and we said, oh, the gods are fighting with each other. Because of that sort of intellectual baggage, now the pendulum is swung all the way over here to where materialism and science explains everything. But now, with more recently, it's swinging back, I think, where God of the gaps in that original sense, oh, it's lightning and the gods must be fighting, that's a legitimate way of explaining reality. But then now, more recently, so is a matter-only explanation. So it feels to me like the pendulum is swinging back, and now materialism of the gaps, or physicalism of the gaps, is also now just as legitimate, in that some of these recent discoveries in science that we've learned in just the past 150 years, all the math that is raising a huge question. I think it, in the same way that originally was right to say God of the gaps, is now becoming right to say materialism of the gaps. And I think that intellectual honesty is important in this moment, to just recognize, like, we are informed by our past mistakes, and it is natural to want to go all the way over here as far as you can, because those silly Bronze Age people got it absolutely wrong. But my big contention on this channel, and you guys will probably agree with this, is let's just try to all stay open-minded, follow the evidence wherever it leads, and if that does bring us back this direction, or bring us back all the way to this direction, but in a totally different way than we had originally understood that, then fair enough, let's go there. But it requires a lot of intellectual integrity, in my opinion.
Yes.
I hear that totally. And I think what's going to cause that pendulum to swing back is multiverse. It's just multiverse is too far. Even scientists, I wouldn't say a lot, but there are significant number of scientists who do not like it. The regular person on the street can see multiverses is kind of crazy once you break it down. I think multiverse is the logical conclusion of trying to avoid God in your explanations, is the multiverse. And I think that's what's going to really cause it to swing back, because it's not sustainable. Multiverse is not, it's popular now and it's rising popularity, but I do not think in the long term it's going to really find its home in science, and it's going to force science to swing back and incorporate an intelligent cause. It seems like a dream, but I think it will. I think it will happen, because I just don't think that real scientists are going to want to believe in a multiverse in the long run. But maybe it's just a dream, but I hope it happens.
Well, if my card has not already filled up, then it's about to. So I'll let you guys land the plane. How can people find you? Where do you want people to go from here to learn more about the work that you guys are doing?
So you could find our podcast, Physics to God, on wherever you find your podcasts. You could also go to our website, physicstogod.com. You could give us your email, sign up. We'll send you a PDF of some articles about that we've written about this, and we'd love to have you. Could also email us at physicstogod@gmail.com.
Awesome. Well, thank you guys so much for your time. Like I said, I'd love to do a part 2, who is God, and get into Isaiah 4, Micah 5:2, etc. We can have that whole debate, but this has been really, really awesome.
Okay,
been a pleasure, Brandon.
Thank you so much, Brandon. It was great to be on today.
It's been fun.
Okay, bye.
Take care.
If you enjoyed this video, please consider joining the Wisdom Society. Support the mission, invest in yourself, join the community.